Okay, everybody, I think it's all set now. Yes, all right. So let's go ahead and take a look at this sheet that I just gave you. So today we are talking about distance and midpoint. So do you remember the distance formula? Don't look at it. If I ask you to write it down, would you be able to? You can? It's fine. So yeah, it's right there for you.
I don't think we did. I really don't think we ever learned that.
I learned midpoint, not distance.
You learned distance just forever ago. I'm positive you did.
No, I've never
I
learned.
remember like the distance was like three times.
Oh, yes, that's true. You're not wrong. You're not wrong. That is true. This, ladies and gentlemen, if you want to find the distance between 2 points on the coordinate plane, it's real easy. If both points are along a horizontal or along a vertical, you could just count. But what happens when the 2 points are not along a diagonal? So let's go ahead and do the one down at the bottom here under examples. I'll come back and talk about midpoint in a minute. So we have -2, 6 and 4, -3. You can graph it, but there's really no need to. Let's see. I'll show you just on here, but you don't have to graph it. If I had -2, 6, be somewhere way up here. And then the other point was 4, -3. Right. So here's my point though, that you can't just count the boxes because it's not perfectly vertical or horizontal. So now I'm in a little bit of a snag, but not really. Because do you remember, couldn't I just turn it into a right triangle and do Pythagorean theorem? Because now look, I do have a vertical and I do have a horizontal. So it's easy to find these values. And doesn't a squared plus b squared equal c squared? That's all the distance formula is, ladies and gentlemen. It is the Pythagorean theorem, but it's just solved for c and it's written for the coordinate plane. This is literally a squared. This is b squared. And then to get c, I would take the square root of both sides. That's all it is. Okay, so I know it looks overwhelming, but that's where it's coming from. Okay, so let's go ahead and try and use that formula and see if we can figure out what the distance actually is. Okay, so yeah.
So in that formula, it's like x2 minus x1 squared.
Yeah.
Under the square root.
Great question. And the answer is no, because, so I don't know if everybody heard his question, but let me reiterate it again because it's a good question. So here's the formula. He said, well, look, you're squaring this and then you're taking the square root of it. Don't they just cancel out? And that is a mistake a lot of kids make. And it doesn't work that way because you're adding these two things. When you have a big old square root, it works like another set of parentheses. It's saying, hey, I'm not going to take the square root of any of this until you've combined it into one term. Once you have one number under there or one expression under there, then I'll take the square root of it. That's actually the last step that we do. So I'm going to have to figure this out, square it, figure this out, square it, add those numbers together, and then I take the square root. Hopefully that makes sense, okay? So let's go ahead and try. The points that they gave us again were -2, 6 and 4, -3. It does not matter which point you call the first point and which point you call the second point, because if I find the distance from A to B, it's the same as the distance from B to A. Who cares? Pick one of them to be your first point and one to be the second. Guys, this is just an X and a Y, isn't it? So is this. That's just an X and a Y. And then we just, since I have 2 points, I just put the little ones after it. Hey, that's just the X and Y of the first point. That's just the X and Y of the second point. That's all. Don't get nervous about that. And now I have this really cool formula to use to find my answer. So we do a big old square root. in there. Let's fill in all the pieces. What is x2? You want x2? 4 minus, what's x1? -2. When you have minus and negative, what happens? Yes, you plus the positive. You're going to square that. y2 is -3 minus, what's y1? 6. Close it, square it. When you put those pieces in, I'm hoping that that's how it looks for you. Now you have to complete the order of operations properly. I do have parentheses. I got to do what's under there first. So I'm going to get 6 squared plus -9 squared. And now remember what I said a moment ago. The big square root acts like a giant parenthesis too. You got to combine all of this into one number. Last thing you do is take the square root. So I'm not at the square root step yet. I got to actually do this out. 6 squared is 36. What is -9 squared? Positive 81. Ladies and gentlemen, it will never matter if these numbers are positive or negative. When you square them, they'll always be positive. So you're always going to be adding 2 positive numbers together. 36 and 81 is, I don't know, what is that? 117, thank you. 117, I don't think I can reduce that radical. I could turn it into a decimal. That'd be, what is it, 9.8? 10.8? Sounds good to me. But see how that's the last thing that I'm doing? The last thing you do is take the square root. Does that make sense? It would just be whatever units you're in. So just units. It wouldn't be squared or anything. That's it. That's it. Yeah. There is a part 2 to the question. Now they say, hey, I also want you to find the midpoint. So that's the distance between the two. And now they're asking for the midpoint. We talked about that just a few minutes ago. To find the midpoint, we're just going to add the x's together, divide by 2, and the y's together, divide by 2. So I'm literally adding the x's, divide by 2, comma, do the same thing for the y's. So everybody, for that same set of points, -2, 6, and 4, -3. Everybody go ahead and find the midpoint if you haven't already. I'll take an answer if anybody's got one. Braylon, go ahead. I'm not sure about your first number. Second number I like. Are you sure it's 2? Yeah. Yep. Okay, so we're doing -2 plus 4, divide that answer by 2, and we'll do 6 plus a -3 over 2. That's how we are arriving at 2 over 2 and 3 over 2, or just 1 comma 3/2. And that's it. So there is finding the midpoint. Is that so bad? Was finding the distance so bad? How about if I do this for you tomorrow? Tomorrow, I'll give you the distance formula. Even though I know it's in there somewhere, but I'll give it to you tomorrow. So if you don't have it memorized, don't worry about it. Okay, let's go ahead and see if we can figure out number 2 here. It says M is the midpoint of segment AB. Point M has coordinates -3, 9, and point A has coordinates -12, 2. Now you got to figure out where B is. You know already? Go ahead.
Find the distance between M and A. And then you add
So you
the 1.2.
could, but there's an easier way. Jake, you have a thought?
So you would set it up as if you have point B using the midpoint formula, and you set it equal to -39. So then you have x2 minus 12 divided by 2, comma y2 plus 2 divided by 2, and then each part set it equal to the corresponding x part.
You're spot on. So what he's doing, let me show you. I'm going to flip to the next page. Now, to find the x coordinate of the midpoint, oops, here we go. To find the x coordinate of the midpoint, don't we add the two x's together and divide by 2? Right? And that gets me my first number, comma, and then I do the same thing with the y's. Y of the midpoint is just y1 plus y2 over 2. So normally I have these two numbers. I add them together, I divide by 2, and I'm done. Here, they threw you a curveball. They didn't give you x1 and x2. They gave you 1 point, so let's call it x1, and they give you this. So you're going to fill in these two and then just solve for that one. Let's walk our way through it. So it says M, which is the midpoint, is at -3,9. And then A is at -12,2. Here's what we know. Yeah, that's an X and that's a Y. That's an X and that's a Y. This is not my first point though. That's the midpoint. I'm going to put little M's after the X and Y. This is one of my endpoints. It's Y2 and X2 that I don't know. Those are the pieces I'm looking for. So when I go to fill all this in, I just gotta make sure I'm putting everything in the right spot. X of the midpoint is -3. X1 is -12. I don't know what X2 is though. But can't you solve that equation now? Can't you solve that for X2? Go ahead. Anybody have X2? Jake? 6. I agree. Did you get 6? So all I would do here, if I were you, I would multiply both sides by 2. So I'd get -6 equals -12 plus X2. And then just add that 12 over to the other side. And yep, I get 6. And now go ahead and do the same thing, solve for Y. Oops. Anybody have an answer for Y, the midpoint? Braylon, go ahead. 16. I agree with you. So Y, the midpoint is 9. Y1 is 2. I don't know what Y2 is, but now I can solve for it. Multiply both sides by 2. I get 18. Minus that 2, 16. So that means that B is located at 6, 16. There is a shortcut to this. I hesitate to show you. Do you want to see it or do you think it'll be confusing? You want to see it? Oh dear. Okay. If you don't want to, just ignore me for a moment. So one thing you can, yeah, go so fast. You really want to ignore this. Okay.
I also go to the bathroom.
No.
I actually have to pee.
No, don't let him go with me. He's gonna do not take me.
Oh my gosh.
He has to fill my.
I didn't mean that in an appropriate way.
Well, I have so much to tell my husband today. Oh my goodness gracious. Can we also cover all of our noses? Thank you. All right, so the The shortcut is, and don't mess this up though, because if you go the wrong way, you're going to get it totally wrong. Start at the end point and go towards the midpoint. Watch. So if my endpoint is A, to get from -12 to 3, aren't I adding 9? If you add 9 again, oh my gosh, look where you end up. And then do the same thing here. I get from 2 to 9. In this case, I'm adding 7. Add 7 again. I'll get you right there. Well, but it's if you don't mess it up, I don't care if you use that. But there's, I mean, you got to understand why it's working.
Yeah.
And I know, but this is how well, at least I told you. So there it is. But you got to make sure you're starting at the end point, going to the midpoint. If you go to the midpoint to the end point, now you're going to get it all messed up. That's going to be wrong. Okay, the only thing left for us to do is find out how long segment AB is, and then luckily to find segment MB, that should be super easy because we know that MB should be half of AB, right? Because M is the midpoint. So let's go ahead and find segment AB. If you haven't already, you know where A is and you know where B is now. So we should be able to use that distance formula and plug in those pieces. So please, everybody, find me where A or the length of AB. Don't look up at my screen until you have an answer. We'll see if we all agree. No, yeah, that's over. Sorry. Yeah, come back. I'm on B, yeah. The one that we just found in part A. 616. Oh, I'm sorry. I didn't realize that was off.
Oh, so that.
Yep. When you have your answer, you can feel free to look at mine and see if we match. Do we? Oh, good. By the way, let me just show you, if you had done, remember Braylon's question way back at the beginning, wouldn't the square root just cancel out the squaring? It's really easy to see here. If you had done that, is 18 plus 14, 22.8? No. So that's just goes to show you're not going to get the same answer. You can't do it that way. You have to combine everything into one single number. And then the last thing you do is take the square root. All right, so there is the length of AB, and then to find the length of segment MB, you could go through all of this again and use one of these 2 points with point M, but you don't have to because you could just, Jake?
You could take half of 22.8 because M is the midpoint.
Exactly.
Two corresponding segments that are created equal complement.
If I know that M is the midpoint, then MB has got to be half the length of the whole segment. So MB must be approximately, what would that be, 11.4 units. There we are. That's it. You could have done the distance formula, of course, and if you had done it, it should have come out to be about 11.4. All right, guys, that is all that I had to tell you about. I do have a worksheet for you to try. Let me see here. Distance and midpoint formula. So let's see. Oh yeah, this isn't so bad. There's 2 questions on the back that deal with triangles.
Whoa.
And let me hand this out and then maybe we'll do one of them together.
Yeah. we're going-
Okay, do not go over. You went. I'm sorry. Go real fast then. I really thought you went.
What?
Right? That was
Nice.
Okay, so I'm gonna do one of the ones on the back. If you want to do one of the ones on the back with me, you can. So let's see. Well, let's talk about the 2 questions. I'll just help you sort of set it up here. So the first one says, given the vertices of triangle ABC, determine whether the triangle is a right triangle. How would I know if this thing is a right triangle or not without whipping out a graphing and taking a protractor? Evan?
You get A squared plus B squared plus C squared.
Ooh, you certainly could. If A squared plus B squared really does equal C squared, then you have a right triangle. So that would require me to have the lengths of all 3 sides. And we do have the tools to find that. There is another option. If you didn't want to do A squared plus B squared plus equals C squared, there is another way that I could check if I have a right triangle or not. Jake?
Well, if, say, 2 of the legs were equal distances, that would mean it would be a right triangle because it would be a special classification, it would be 45, 45, 90. That could be 1.
But what if you had like an obtuse isosceles triangle? You'd still have 2 legs that were the same. So how can I guarantee that I have a 90-degree angle at one of the angles in the triangle? I wouldn't need to test all of them. I would just need to see if one of the angles is 90, right? Yeah, go ahead.
Well, with the slopes,
Yeah, so you could do that too. You could test the slopes of the 2 legs and see if they are perpendicular to each other. Either way is going to work out for you just fine. So it just depends. Do you want to find the distance of all 3 sides, or do you want to find the slopes of the 2 legs and then test if they're perpendicular? So that's how I would attack number 1. Number 2 down here is asking you, hey, is this triangle isosceles? So do you remember what isosceles even means? Close. 2. Yeah, so 2. So this one, now that you remember what isosceles means, you could find that relatively easily by finding the length of your 3 sides and seeing if 2 of them are the same. Does that make sense? Okay, so I will do one of them out. Does anybody have a preference over the first or the second? I'll do the second. So I just have to find the length of all 3 sides. So make sure that you're keeping track of which one you are doing. So the distance of AB, for example, you're gonna subtract your x's. So -5, oh, stupid pencils. -5 minus 1. close it, square it. Same thing with the y's, -3 minus 4. Close it, square. And now you're just evaluating. Oh, it's 36 and 49. 85. Yes. Okay, I don't even need to go into decimal. You could, but if I get square root of 85 for another one, then I know my answer is a yes. So I already did AB, so now maybe I'll do BC. That would be 1 minus -1 turns into a plus, close it, square it. Y2. 4 minus negative turns into +5. Yes, I don't even have to keep going. Because I found 2 that are equal. So the answer is a yes. Now, here's a little tidbit. I don't know if you remember from geometry. I know you might be thinking, well, wouldn't you have to test the third side? Because if all 3 of them are the same, then wouldn't it be an equilateral triangle? Technically, yes, but did you remember that the definition of isosceles triangle is not a triangle that has exactly 2 equal sides, but has at least 2 equal sides? It could be both. Yeah. So every equilateral triangle is technically isosceles. So I don't have to bother checking the third one. You could. It'd be a more specific name. If I found out that all 3 were the same, you'd usually want to use its most specific name, which is equilateral. But technically, I already know that this thing is isosceles. I don't have to go any further. Can you? Of course you can. I don't know if it comes out to be the same or not. I don't remember. But yeah. Yes. So for the first one on that side, you could do the same thing. You could do all 3 and then test it in Pythagorean theorem. Or you can, well, actually, I guess that's a good point. How do you know who the legs are? You wouldn't know without doing, you could do 2 things. You could either actually graph it and then see which 2, who's the hypotenuse and then which 2 are the legs. Or if you did find all 3 lengths, you would certainly be able to tell from that who is the longest. Yes. Yes. Okay. Are there any other questions that anybody has right now? No, we're okay. All right. So I am going to, I don't think I've stopped this video yet. Did I? Nope, I guess not. I'm going to stop this. I will make this live for you on Jupyter so you could submit it when you're done. It sure is. Whatever you don't finish in class. Oh, okay, I'll check. Okay. That's fine.